can see here, all up around here, is a rock known as the Green Valley tonalite. So remember that we have three types of rocks in the rock site, three major rock types. We have your igneous. This is rock that starts out as liquid, then solidifies. You have your sedimentary, which starts out as products of erosion, whether it be ions or small pieces of rock or weathered pieces of rock, and ends up getting deposited and then undergoes diagenesis. And then finally we get your metamorphic rocks, which are put under pressure and or heat until the mineralogy and crystal structure changes substantially, but not until it melts. So what you can see here is probably the spillway. I'm not sure where these rocks have come from, but you can see right here along the sides, I'm hoping this is it. It's a little hard to see around here, and I'll explain why that is in a moment. Is there a formation known as the Green Valley tonalite. Ignore these black boulders, those are probably gabbros from San Marcos. Yeah, let's see. It's hard to see anything here. So Green Valley tonalite, this is basically a granite with a little bit more calcium feldspar. That's your tonalite. You notice that it's kind of looking pretty dirty and dusty. So what we're also looking at is something known as what's happening here is that chemical weathering has attacked this rock face for many, many millions of years. This is the oldest formation. It's about 105, 115 million years ago. I'm going to just guess, shooting from the hip. Somewhere in that range. And there's been several instances where this rock has been at or very near the surface, and when it's out near the surface, you can see water percolates down these cracks. Oh, it's really nice being in the shade here too. Everyone like the shade? Yeah. And you can see that the water reacted with the calcium feldspars and caused it to weather quite a bit. Yeah, we don't have any really good raw exposures. We'll get more raw exposure of the Green Valley tonalite in a little bit. If you look up the spillway here, there was a beautiful exposure of it on the spillway. Why they put the concrete lining here, every geologist I have read the writings of on this place has no freaking idea why they've done that, because tonalite doesn't erode that fast. In fact, it's pretty resistant to erosion, so if they put this here to reduce erosion, it's sort of like, it's not really, this wasn't probably the most needed place for it. But, okay, yeah, starting to weather. We're seeing quite a bit of chemical weathering. This is not just recent. You can even see some like spheroidal weathering here. You can see that weathering's attacked the corners a little bit. You can see that some of these blocks, even in the cliff face, are looking kind of sphere-like. But some of this, oh, here's one that's in place. Perfect. Hold this for me. Yeah. This is probably Green Valley tonalite. I'm gonna guess. Yeah, this is it. This is a good sample. So you can make good food out of it. So again, what's happening here is that you can see further up, you can actually see a pretty well-developed soil horizon up here that's supporting fairly rich vegetation. And you can see the organic rich layer that's being held together by the roots. You can see that then there's a zone where nutrients are being leached out of the soil. You can see a band where nutrients are accumulating. This is all chemical weathering. Water is removing ions from the rock, leaving behind clay minerals and other sort of secondary weathering products, but also leaching out some ions and concentrating them in other areas. Most aluminum deposits, for example, a number of them anyway, are actually start out as aluminum-rich rocks in tropical soils. The aluminum ions get weathered out of the upper layer of soil, get precipitate in the lower parts of the soil horizon, and you get actually enough, you get pretty rich ore. And if you're bauxite. So yeah, and so what basically we're seeing is we're starting off with igneous rock, and then we're seeing weathering, chemical weathering take place, breaking down into sand and clays, clay minerals and ions. Oh, there are some micas too. Micas are, I don't want to call them clay minerals, but they're very similar to clay minerals. They both have very sheety chemical structures. So, oh, it'll be a mixture of many different mineral types. The areas climate has changed here quite a bit over the times that rock's been exposed here, and so chemistry of what's... And this is a fairly diverse area rock-wise. You see up above there on that hillside, you can see a little, looks like some sort of little deposit. I can't quite piece out what that is. That might just be part of the dam construction, but it does continue down the valley for quite a bit. Oh, there's something that's definitely in place, yeah. Now I see a piece of rock that's in place. Wow, God, this bag is way too freaking heavy. Yeah, this one right here is probably in place. You can see very beautifully the jointing, yeah, and you can see that different parts of this rock have weathered just a little bit differently just because chemical weathering's a fairly slow process. This is why if you lose topsoil from a farming area, it's going to take a long freaking time to build it back up, even if you're doing everything right. There are certain farming practices that try to speed this up and are notably effective, but yeah, you can really see the weathering and breakdown of the rock here. In fact, you can feel it. If you touch this rock, it will breaks apart in your hand. Oh, if you realize something exciting, try grabbing some of this. So, there we go. This kind of looks like solid rock, but what's happened is the chemical weathering has attacked the feldspars and more easily weathered minerals that are holding together the quartz grains. Weathered out those ones, the quartz grains are then basically have nothing left holding them in place. They're not going to react with water very vigorously, but they are going to fall. Yeah, so the quartz grains get mechanically weathered, but the stuff that holds them together gets chemically weathered. Oh, here we go. Probably shouldn't be on film. Here we go. Take a piece. This is pretty... If you hold this in your hand, it will crumble. This is decayed... This is what we call decayed granite or rotten rock. And so again, this is weathering. Yeah, so chemical weathering loosens as like weathered away some of the minerals that hold it together, and and there are still minerals that resist it, but there's nothing holding those. There's no glue between them, so they sort of...
That's just water.
Yeah, water, wind, a little bit of carbonic acid. All the good stuff, yeah. In fact, it's thought that one of the things I don't go into with enough detail is that the weathering process is a little bit enhanced because rainfall usually has a little bit of carbonic acid. Oh, is that totally? Let's take a look, yeah. Likely. Again, I'm not sure exactly where we are with being allowed to grab samples from here. I'm on camera, so yeah, this is, oh, that's definitely tonalite. I can just tell because it's weathered. Generally, I can tell that it's probably from here because it looks heavily weathered. You can see these boulders in the canyon here. This is clearly something that was trucked in. And the way I can tell is because these are nowhere near as weathered. Generally, when you're looking for rock to sort of control erosion, you don't want something that's been heavily weathered. You want something that's, or also most quarries, once you get far enough down in the quarry, you're below the weathering zone, so you have fairly solid rock. Yes, that's definitely totally, oh, that is a beautiful sample. I want to get a picture of that.